One. Welcome to our presentation. My name is Yahong Lian. I'm from Inner Mongolia University of Technology. The paper called a contrastive learning-based CNN-GRU model for time series and its application for water quality prediction has been accepted by CSCI 2022. And let me briefly introduce our work. Firstly, I want to deliver background. Nowadays, water quality monitoring is of great importance in both sustainable development and intelligent city construction. Prediction of water quality can help control water pollution and protect human health in the long run. To analyze water data with some machine learning or deep learning models, one of the main challenges is that the lack of labeled data. With the awareness of environmental data monitoring in China recently, more and more institutions begin to collect the water data or some related environmental data and post it on their platform to let related researchers do some meaningful study. And we should claim that water quality is one of the classical field of time series data, which means the data will change with the time period, and it is an important indicator for revealing the ecological status. Secondly, we want to talk about previous work related with water quality prediction. Mainstream water quality prediction models can be divided into two types. One is traditional models, includes autoregressive integrated moving average model, support vector regression model, and so on. The other category is neural network models, for example, backpropagation neural network, recurrent neural network, gate recurrent units, and some other refined models. Compared with traditional models, deep learning based models can extract more sophisticated patterns which hide behind time series data. So mostly deep learning or neural network models will obtain more robust and better performance. Furthermore, contrastive learning focuses on learning common features between instances from the same groups and distinguishing differences from the different groups of instances. Contrastive learning is appropriated for a reality of water quality data because of this data is lack of labeled information. So our contribution can be as follows. We apply contrastive learning technique, which is a typical unsupervised or semi-supervised representation learning technique, and we propose a contrastive learning-based CNN-GRU fusion model, which consists of two parts. One is a data augmentation scheme, and the second one is CNN-GRU modular, and we will discuss it in the later. To show the effectiveness, we conduct comparative experiments on groups of public data, and we also conduct our proposed model on a real-world water quality prediction task. Thirdly, we will deliver our model in detail. The overall framework is contrastive learning based. Specifically given two time series data xi and xg, which is drawn randomly from our training data. An augmented training example can be constructed as xi constructive data equals to lambda multiply xi1 plus 1 minus lambda multiply xi2, and we got 3 data and fit it individually into the encoder modular to get the more refined representation hi1, hi constructive, hi2, and then we also feed these three data into the underlying projection head modular, and finally we predict the amount of mixing. The encoder parts or modular is mainly used for transform the input data into a new refined hidden representation, and in this representation can obtain or extract more useful, meaningful information or knowledge from raw data. And next, the new representations are transformed into a task-dependent representation by projection head modular. And for individual one instance, we can calculate the contrastive loss as this formula shows, where sim function denotes the cosine similarity and the symbol tau denotes a temperature parameter, which is very common in contrastive learning-based loss function. And the fourth part is our experiment and conclusion. To evaluate our proposed model, we conduct comparative experiments on some public datasets and also choose some baseline methods. For example, RID represent the raw input features methods. In this scenario, we apply raw time series as input without any transformation, and the HC represent handcrafted features-based methods, and the AE denotes the autoencoder features-based methods, and also CL denotes the SIMCLAR features-based models. And the CLCG columns is our proposed models. Besides that, we also do a case study on real-world water quality data sites, which consist of total 328 sets of data were chosen from November 2020 to September 2021 at Ardalhezi in Tongliao, Inner Mongolia, China. And the proposed model is used to predict water quality in multi-classification task. We also do correlation analysis of water quality data, and from figure 4 we can see that the dissolved oxygen DO is an important indicator for the water quality and the self-purification level of water bodies. And table 3 shows the experiment result. It can be seen that the model has a good fitting effect in real-world water quality classification tasks, so we can utilize these models instead of using manual computation, which is time-consuming and inefficient. Finally, to sum up our work, in this paper we present a contrastive learning-based CNN-GRU model, which combines the benefits of contrastive learning technique and the good point of CNN and the GRU model. To show the effectiveness of our proposed model, we conduct comparative experiments on both public time series datasets and one side of real-world datasets. Okay, that's all. Thanks for your listening.